Now it's the moment of Yizhou from California Institute of Technology. She has a paper on time-varying risk aversions, evidence for near-miss accidents. You need certainly the...
Okay. This doesn't work. Oh, okay.
Yes.
Okay. Great. Hi, everyone. Thank you very much for having me here. It's a great pleasure to be here and to talk about this recent paper, which studies the driver's behavior using some telematics data from China. Okay. This is a joint work with one of my colleagues at Caltech, Matthias, and any of your comments or feedback would be very much appreciated. Okay. So let me start with the motivation. So as you may have already known, risk aversion is one of the most important key preference parameters that can determine individuals' economic decisions. For example, their risk preferences is definitely related to people's investment decisions, their saving behaviors, and of course, their choices of insurance plans, both in terms of health insurance and auto insurance. And your risk attitudes are also related to the adoption of new goods and technologies, etc. Right? So it has been a long time in the literature that people are making assumptions, assuming that the risk attitude is actually kind of a stable attribute and it's fixed over time. And there has been some empirical evidence showing that there is a huge variation of risk attitudes cross-sectionally, and some papers have estimated the distribution of these risk aversion parameters across a large population. But more recently, there has been some very interesting survey evidence suggesting that actually the risk aversion may change over time, and in particular, it can be shaped by these very some recent and mostly adverse experiences. For example, there are survey evidence suggesting that after the financial crisis, people become more risk averse. Even some of these very professional bankers, they become more risk averse. And also people have seen evidence of suggesting that after earthquake and tsunami, like these natural disasters, people also become differently, and they are more risk averse. And there are also evidence related to the change of risk attitude after experiencing violent conflicts. Okay. So in this paper, what we are trying to do is basically to provide some evidence for time-varying risk aversion and using data from the field. Okay, so in particular, we're going to take advantages of these very kind of unique and novel high-frequency data, high-frequency telematics data on driving behavior. And the research question that we're trying to understand is, do these adverse events, such as driving mishaps, can essentially trigger the changes in people's risk preferences and eventually lead to a change in their driving behaviors. And if this is the case, then we want to understand in which direction people become differently, and also what would be the potential welfare implications of these changes on the insurance markets, basically. Okay. So in our paper, we focus on a particular type of adverse events, which is we call the near-miss accidents, or in other words, we can also call that the close calls, basically. Okay, so essentially these, we can use the telematics data to construct these near-miss accidents or these driving mishaps using the directly recorded information in terms of the people's behavior, like hard brakes and hard turns. Right, and we find to answer our question is actually better to use near-miss accidents rather than the real accidents. Well, the main difference here is that near-miss accidents are definitely more frequent in the data, while the real accident happens rarely in the real data. So you don't observe that events a lot. And more importantly, the near-miss accident as far as we know in the current pricing current empirical strategies, these are not really considered in terms of like punishment. So near-miss accidents do not trigger an actual change in the insurance contracts in most of the existing cases, right? So then compared to real accidents, if you had a real accident, after that, your future incentives become different because you are facing a different pricing strategy after an accident. So that may already give you some pecuniary incentive to adjust your driving behavior compared to if you experience just a near-miss accident, there is no change of pecuniary incentives. So your reaction can be more attributed to your change of preferences or some other factors that can change your behavior, right? Okay, so in the psychology and some sociology literature, people have found some lab evidence suggesting that near misses can induce behavior change. And the rationale behind this is mainly that these near miss attenuate risky behavior if they are recognized and interpreted as disasters that almost happen. Okay, so the paper, we are using the data from essentially a Chinese insurance technology firm. And this firm is producing a mobile phone application that help to track users' driving patterns using the existing phone functions. So this technology firm, it's not an insurance company by itself, but it develops these apps to collect telematics data from the drivers. And at the same time, it also serves as a front-end auto insurance brokerage. So it can individuals can basically also purchase insurance products from this platform. Okay, well, the platform serves as this insurance brokerage. Actually, in our sample, mostly in the early years of these development of technology in China, few drivers actually purchase the insurance through the website, through this platform. We only observe about 6% of them actually request insurance quotes. Okay, so one important feature in our data is that, so the information users' driving patterns, it's not used in the insurance pricing. And this is mainly because this company by itself is not an insurance company, and they are just selling the products and the price is determined by the insurance companies by themselves. And of course, the hope is that in the end, if they have enough information to generate a better predictor of people's behavior, then the insurance company can take advantage of these measures. But at the current stage, the company is mainly serving as a data collecting agency for people's driving behavior. And so because of this, the drivers in our sample, they have little incentives to actually improve the driving based on some of the feedback they get from the app. Because the driver knows that even if they improve, none of this information will be actually reviewed to the insurance company for them to get a lower premium also. Okay. So the data we get, it's a pretty detailed trip level information, which covers about a representative sample of more than 56,000 drivers. And the time horizon we're looking at here is about 3 years. So we observe for each trip, the starting and ending time and location of these trips. And we also observe very important measures reported by the app directly, such as whether the agent has any hard brakes, hard turns, aggressive accelerations in the middle of the trip. And we know exactly when these things happen, right? And from these observables reported by the app, we can essentially construct our measure of driving mishaps or near miss or close calls. And in the data, importantly, we also observe several different measures of individuals' risky behavior, such as you may be using your phone while driving, like texting or making phone calls, or you may be driving at night, or you may just driving on the highways, right? All of these factors are kind of important risk factors to predict the occurrence of accidents, right? For a subset of users who indeed requested insurance quotes via the app, we're able to collect additional information in terms of their demographics, the characteristics of their vehicles, and we can also match some of their insurance claims data with their driving behavior. So the sample size for this type of data, it's small, but we're going to use some of them to conduct like robustness checks. Okay. So here is a table I'm trying to show you our measures of near miss. So as I already alluded to, we are mainly going to be relying on these measures of hard brakes and hard turns. And you can see that, so on the first top panel of this table, if you just use like whether there is a hard turn, so first of all, we are summarizing basically the frequency of hard brakes and hard turns at a user daily level in this table, right? So if you just use hard turns, and it's actually pretty frequent in the data we observe, right? So like in almost like 70% of the days for each user, you will have some hard brakes. But then we come up with this new measure, which takes into account both the hard turn and hard brakes, and also the aggressive accelerations. And the rationale behind this is that basically people sometimes just get some accelerations and they need to slow down, right? And at that time, they may just hit the brakes, right? So we prefer to use a measure which is the hard brakes and turns accompanied by aggressive acceleration, because these are the hard brakes and turns that are more likely to be preemptive actions and more likely to be related to the actual expected near-miss accidents. Okay, so based on this preferred measure, we find about 30% of in our sample periods we see one near-miss accident. Okay. So I don't have time to show the details, but we correlate these constructed measures of near miss with some real accident records, and we do find that there is a positive correlation between these measures, which gives us some validity of these constructed measures. Okay. So yeah, this table and what I'm trying to show you is basically these summary statistics for these 6 dimensions of driving behaviors, and you can see this is like kind of normal compared to like national averages and so on and so forth. And people do sometimes use their cell phones while they were driving. Okay. So, okay, now let me try to show you these our empirical evidence, which suggests that people's behavior may have changed after experiencing the near-miss accident. So in this table, what I'm trying to present is, let's say we call the day that you have a near-miss accident as day 0, and then you have day 1, 2, 3, 4, and so on and so forth, right? And just by providing you this table, I'm showing you on each day, starting from day 0, what is the average level of these risky behaviors across different dimensions, right? So as I have already highlighted here, you can see that starting from day 0 to day 1, there is like a big drop in terms of many like risky behaviors such as phone use, distance, duration, driving at night and highway. The change in terms of speed is not actually very significant from this table, right? So just at this from this table, at least at the face value, we can see that basically their near miss accidents seem to precipitate a sizable drop in these risky behaviors. Of course, this is just like a pure summary statistics, and there may be many other confounding factors to generate this table. So what I'm going to do next is to show you some regression results that can help us to highlight these causal effects of the near-miss accidents on the subsequent risky behavior. Okay. So we are going to estimate the effects of near-miss on risky behavior using the following dynamic panel regression model with individual fixed effects. So here, this notation YIT is going to be one of our 6 measures of risky behavior. And the coefficient of interest is this beta coefficient, which is basically if you have a near-miss accident at t-1, what's going to have, how is that going to impact your risky behavior level at period t, right? So we want to recover this beta parameter. And in this regression, we also control for many individual observable characteristics. And importantly, we also include these alpha I, which is not directly observable in the data because it's an individual or like a driver level fixed effect. And to some extent, this alpha I could capture like the hidden riskiness of a driver. For example, if you're a more risky driver, of course, you're gonna experience more near-miss accident. At the same time, in the data, you will be observed as like having more risky behaviors, right? So we want to take into account these unobserved heterogeneity in terms of the agent's riskiness. Okay, so and again, this epsilon term is just like a random shock that is uncorrelated with these control variables. Okay, so in order to deal with this unobserved heterogeneity across drivers, we need to basically take the difference between two consecutive time periods to eliminate these unobserved factors. But even after doing that, we still have some potential endogeneity issue in terms, in the sense that, for example, you can imagine users may experience shocks that can jointly precipitate near misses and also risky behavior, right? For example, if I'm suddenly have like an emergency situation, I may just need to drive a long way, and at the same time, I may also like have more accidents on the road. So there could be these factors that jointly affect near miss and also the risky behavior. And so in order to deal with this situation, we're going to use the weather condition from the previous period to serve as an instrument for the near miss accidents. Okay. So here I'm showing you the table of our regression results. So all the numbers you see from here are the beta coefficients, right? You have many, many other coefficients in the regression, but for the sake of time, I will just skip those. But I want to highlight we are running these regressions for different risky behavior separately. So each column corresponds to a different risky behavior, and each row we are using different constructed measure for near miss. And you can see there are consistent patterns, at least for 4 out of 6 risky measures. For example, we see that after near miss, we see a significant decrease in terms of these like distance. So you basically reduce like 12 kilometers after you, for your driving distance after you experience near miss. And similarly, you see that effect on duration for use and highways. But we do not find actually a significant negative effect of near miss on the driving speed or the behavior of driving at night. Okay. So, okay, so then the next question in your mind is that, okay, we know that people may have changed their behavior after experiencing these negative events, but then to what extent this effect lasts, basically, right? So based on the dynamic panel regression model, we estimated from from here, we can essentially calibrate how long does it take for these decreased level of risky behavior revert back to these original levels, right? So the figures on this slide, I'm basically showing you that for different risky measures, for the 4 of the measures which we see a significant decrease, it in general takes like 5 to 6 driving days. What I mean by driving days here is that people are not driving every day. So in the data, we see that the average gap between the 2 driving days is like 3 days. So if you consider the effects goes away in terms after 5 to 6 driving days, and it's about equivalently like 2 to 3 calendar weeks. Okay, so the key message we find here is that we do see that there is a significant effect in terms of people's risky behavior. They drop their risky behavior after experiencing negative accidents, but there is also like a very strong recency effect that in the long run, these more cautious driving behavior basically goes away and it reverts back to the original level. Okay. So in the paper, we have more discussions in terms of the robustness of our results. But here, I just want to highlight 3 key subsamples analysis we're doing here. So we're running the same set of regressions for more experienced versus less experienced drivers. And we find that even for these very experienced drivers, we see that they reduce their risky behavior levels after experiencing these negative effects, which it's kind of interesting and tells us that the pattern we learn from the data may not be fully contributed to like a learning story, right? Because you can imagine that more experienced drivers know better about themselves, know better about their own risks. So they're responding to these negative effects are mainly the fact that we see they also react to these negative events can tell us more about that. This is maybe related to the change of preferences after the near-miss accidents. So we also ran regressions for the near misses which occurred on the familiar roads versus like unfamiliar roads, and we find similar effects on both. And this is also suggesting that even for people who are kind of familiar with the situation, they still react to these near-miss accidents, and this kind of mitigate the concern that everything we see in the regression, it's driven by the story of learning. And the last robustness check I want to highlight here is that we also compare our regression results for both the routine drivers versus these non-routine drivers. And one caveat of using this telematics data is that you sometimes don't know who is actually driving, right? So it could be just me having my phone, but I'm sitting on my husband's car, right? So you really can. It's really hard for you to detect that from this data. But we think that for these routine and more like a community, people who are commuting every day, they are more likely to be the driver themselves. And so we still find robust results using the subsample of commuting drivers. Okay. So after this empirical regression evidence we provide, the second part of my presentation, I want to talk about a simple model we built for drivers' choice of risky behavior. And we want to estimate this model and to understand whether and how much the change in their risk, in people's risk aversion, can explain the changes in risky behavior before and after the near-miss accidents. And then from there, we can draw some interesting policy implications. Okay, so our model is actually pretty simple. So we just have a driver. Each of them have like a CERA type of utility function. And here in this notation, C represents a risky payoff, which depends on whether there's an accident. And rho is the parameter that we want to estimate. This corresponds to the individual risk aversion parameter. Okay, and we're allowing that if you experience a near miss, and your rho parameter can actually be different before and after. Okay, so in terms of payoff, we allow that to some extent people enjoy having some kind of risky behavior because you may need to pick up the phone, or you just enjoy driving using high speed and so on and so forth. So you have some utility from conducting these a risky behavior, but at the same time, you also have to pay the cost if you experience an accident. So here, this kappa is our notation for cost of accident, of real accident, and we calibrate this number from the data we have. So on average, we see that if you have an accident, you have to pay about $1,000 out of pocket if you have no insurance coverage. But if you have 10 or 20% deductible, the amount out of pocket is much lower. Okay, so this number we're gonna take as if it is given. And the key interest is to estimate the risk aversion parameter before and after the near-miss accidents. Okay, so so given this utility parameter, the agent is just making the optimal choice to maximize his or her expected utility, where the agent's utility depends on, of course, to what extent a net accident can occur, right? So the part I highlighted in red, it's the probability that there's an accident conditional on your characteristics X and conditional on your choice of risky behavior, right? If you drive with a high speed or if you drive longer time period, then you're more likely to have an accident. And this distribution is also can be directly estimated from our data. So these are something we take as given. Okay. Okay, so here is the brief, here's the table to tell you our main estimation results. We find that actually for all specifications, after the near miss, there is a percentage, there is at least like a 10% change in terms of people's risk aversion parameter that is needed to rationalize the change of the reduction of risky behavior we see from the data. And in some other specification, we see that this change of risk preferences could be as large as like a 40%. Okay, so the final part of my talk, I want to highlight these kind of policy implications of this finding that people become more risk averse after the near miss accidents. So the rationale here is that if you have a near miss, then people become more risk averse and they reduce their risky behavior. And in the end, it will lead to a reduction in the cost of insuring these drivers, right? So in order to calculate to what extent the cost can be reduced, we need to estimate some numbers from the data. For example, we see that in our data, the cost of an accident is around 7,000 Chinese yuan. And from our like dynamic panel model, we know that basically it takes about 2 to 3 calendar weeks for these reduction of risky behavior to go back. And so based on this, we can calculate the reduction in probability of an accident and also the reduction in cost, which is for each near miss you see in the data, it corresponds to like a 2.7 and 5.2 Chinese yuan, given our estimates. And of course, we want to kind of compute like an annual level reduction based on these estimates. So in our data, we find, so from some survey data, we know that in general, people in China drive about 200 days a year. And if near miss, which based on our data occurred on about 10% of these driving days, and you take into account this information, you can calculate the annualized reduction in insurance cost due to people's change of behavior. And the number is highlighted in this red, which is we see a reduction in cost of insuring these people for about $180 to like $120 basically. And if you compare this number to the average auto insurance premium that people pay in China, which is about like $5,000, it accounts for about 2 to 3%. Well, you may say that 2 to 3% of these premium charges, it's small, but if you think about this gigantic Chinese auto insurance market, this is like actually a huge amount in terms of premium reduction. Okay. To summarize, basically from our finding, we see that following these near-miss accidents, drive more conservatively. We see a reduction of this driving distance for about 12 kilometers. We also observe a big drop in terms of cell phone use and highway uses. And the effects, although it's kind of more not long-lasting, it lasts roughly 2 to 3 weeks. And we find that these changes in behavior are consistent with an increase in their risk aversion for about 10 to 40%. And the implied accident cost reduction amounts to about 2 to 3% of the average car insurance premium that is that people are paid for their auto insurance in China. Okay, so my last slide here, I want to briefly talk about the policy implication of our findings. So the finding of these time-varying risk aversion, in particular, the people become more risk averse after these adverse events have implications for the insurance pricing. So as we are here today to talk about experience rating, so this experience rating or bonus malus mechanism, it's a pretty dominant pricing scheme in the industry almost all over the world, right? However, the logic underlying this could be a little bit reversed if we take into account that drivers may become differently after the accident. So if drivers indeed become more risk averse after experiencing these negative events, then an algorithm that takes that into account may kind of correct the over punishment that may be placing on the drivers after these negative events. And I want to also emphasize that our paper mainly takes advantages of this telematics data, and we focus on measuring these very high frequency variations in driving behavior, whereas in the current like real world reality, the changes in these insurance premiums occur at a very lower frequency, typically like annually or semi-annually, at least in the US. And so our results are potentially more directly related to the design of a more real-time dynamic pricing policies in the auto insurance markets, which I'm definitely happy to chat more offline. But this is everything I have for today. Thank you very much for your attention.
Do you want? Okay. We have from near miss to real missed, because we have Stefano Rossi and Matthias Rodemeier. We have some difficulty to reach us. So I would suggest to anticipate the paper by Professor Jin, and then have an entire discussion also with your questions after. Please, Professor.
Thank you. Hi, everyone. Oh, let me get the clicker. My name is Yizhou Jen. I'm a professor in the business school at University of Toronto. I'm going to present to you results from 2 papers that I have on US auto insurance and the use of telematics data. Okay. So before I begin, I just want to say a word about the experience rating, given our topic. It's a very old idea. One of the first use cases I could find is in the 1880s. You have Germany's Bismarck's social insurance system, in which the industrial accident insurance featured quite coarse but yet experience rating for member firms, primarily, and I quote, as a means to reduce accidents. So this moral hazard effect has always been pretty front and center in terms of the design of experience rating. I fast forward to today, I think modern experience rating are adopted widely across private insurance industries in particular, and we have quite a lot of accidents across several different types of insurances that they're very effective at claim mitigation or ex post moral hazard, to Professor Fang's talk earlier, but there's mixed evidence on accident prevention, meaning that maybe I can prevent you from filing a claim or utilizing insurance, but it's very difficult to understand whether that's actually preventing people from incurring that accident in the first place. And at the same time, we also have more data, so finer ratings, which leads to penalties, high penalties, reclassification risk, effectively reducing risk sharing, right? And lastly, accidents are useful to reveal risky drivers, but if we're talking about telling someone's risk that's 0.01% versus another person that's 0.02%, accidents are not very helpful, right? Because you need to wait a very long time for you to have any confidence in that. So one of the most important disruptive technologies in this industry, I would say, is the use of telematics data. If you think about how the economics of this type of data differ from the economics of traditional rating data, I would say there are 3 main differences. One is that rating data typically are mandatory. Your claims are automatically recorded, right, for legal purposes and due to industry data sharing. But for telematics data, we're mostly talking about voluntary disclosure. You have to incentivize people to disclose this type of information. The second thing is that in the industry, claims data and rating data have data sharing across insurers, whereas telematics data are typically proprietarily owned by each individual firm. And lastly, rating data are typically what we call outcome data, meaning that you can be a risky driver, but we rate you based on whether you get into an accident as an outcome. But telematics data is behavior data, so it changes the structure of the contract. So my first paper looks at telematics contract by a large private passenger auto insurer in the US with a focus on voluntary disclosure so to sort of identify what's driving what kind of drivers to disclose this information, to choose this type of contract, as well as what's the impact of this firm owning this data as opposed to sharing it across insurers. And the second paper I'm going to talk about focuses on a self-insured ride-sharing firm in which the focus is really to think about how do we contract very finely on this type of driving behavior? How can we achieve innovations in that sense? Okay, so before I'm going to focus on the results of these two papers, but I do want to say from working with actuaries for many years, there are some methodological differences. More accurately, we sort of built on top of actuaries in two ways. One is that we use economic theory to model how consumers and firms respond to incentives. That's kind of the focus of our study. And second is that we tend to use experimental or quasi-experimental evidence to identify in reality how these responses actually go, okay? So that we can construct this counterfactual world. So like what would happen if, you know, for example, firms are required to share their telematics data with their competitors. This would change pricing. This would change how consumers select it into different contracts and their sort of accident rate through moral hazard, et cetera, as you will see in the talk. So corresponding to the three main differences in the economics of telematics data, I'm going to ask three kind of questions. One is how should firm price on telematics data to incentivize disclosure while capturing rent from the data? And two is how should this pricing of telematics data moderate risky behaviors to prevent accident? Is it achievable? And the second big question would be, what if regulators mandate the firms must share proprietary data with competitors? Okay? So jumping into the first paper. So this is the type of OBD telematics program that I'm going to be talking about, which is a device that you can plug into your car like this. Okay, so specifically in this case, a typical auto insurance contract is at month 0, you come to the firm, you make a coverage choice, and then the period actually in this case lasts only 6 months, at the end of which you need to decide whether to stay or to leave the firm, which I call attrition choice, okay? And in month 5, the company will give you the renewal offer to say that, oh, your rate decrease or increase or stay the same. So experience rating in this context work like this. Suppose you get into an accident in the middle of the period. You're going to file a claim, maybe pay some money out of pocket, OOP, and then the insurance company will send an adjuster to evaluate the claim and potentially give you a reimbursement. But as soon as you get into a claim, this record is reflected across all firms, right? So your renewal offer or your quote from other firms will reflect that increase. So the monitoring that's sort of being done in the telematics contract works like this. In month 0, at the same time that you're making a coverage choice, you're also choosing whether to opt into monitoring. And if you do, you're going to be monitored in terms of your mileage, heart rate, speed, and late night driving record. And if you do opt in, you have up until 5 months to accumulate about 100 to 150 days of monitor driving. And if you succeed in doing that, the company will use that data to determine a renewal discount that's appropriate for you. That's going to be applied forever starting from the next period. Okay. Importantly, this only happens in the first period, and the renewal discount range is also told to the person in the beginning. So during monitoring, there's also some real-time feedback. For example, when you make some of these risky behaviors, the device is going to have a little beep. At the end of the monitoring period, we're going to see a score and the corresponding discount, which we verify with filing data to be proprietary to this particular firm. Okay, so here I'm going to first show you some evidence that tells you that monitoring is broadly useful in 2 ways. In this graph, I'm plotting this gray line, that is sort of the average claim progression for the opt-out group, benchmarked to the very first period, okay? And this is after controlling for all of the pricing observables and state calendar year fixed effects, meaning that sort of this is sort of the within risk class variation. And this is the orange line here is what happens in the opt-in group. The first thing you can see is that during the very first monitor period, there's a very significant drop. In fact, there's a 30% drop compared to the post-monitoring period. So monitoring really changes consumer behavior in the sense that driver becomes 30% safer when they're being monitored compared to when you take the device away afterwards. Right? This is pointing to an incentive effect, meaning that drivers can exert effort to send a better signal about their risk type to the insurer. But despite the fact that people behave differently, right, it still seems like, in general, the opt-in pool is just safer than the opt-out pool, which is telling you that there's some advantageous selection into this pool, right? In fact, we did verify this by showing you that telematics data still signals unobserved risk differences across drivers post-monitoring, even though like drivers drove better during the first period when they're monitored. And this is telling you that there's a selection, or I call allocative effect, in the sense that better risk rating, like being able to tease like drivers apart, can potentially lead to people choosing better plans and therefore increasing welfare. Another result that we use our demand model to show you is that most drivers who can financially benefit from monitoring actually did not opt in, because the average like participation rate in our data is only about 10 to 20%. And we sort of quantify this friction against telematic opt-in to be about $93 on average, which can reflect things like privacy and hassle cost. And we also find it to be more severe in higher risk class, and also more severe for privately riskier drivers, which exacerbates this advantageous selection, right? But this is not the only demand friction. We also see friction against the firm switching costs to be on average, it costs the average consumer about $284 per year, which is to say that privately safer drivers that are originally at other firms, just because my firm start to offer telematics contract, it's not like all of the safe drivers are going to automatically switch to my firm, because they still need to face this very high switching cost. Right? And in fact, this is also one of the most important source of market power in the absence of proprietary data. Okay, so one caveat is that without market level claim and coverage data, meaning that because we cannot track the same customer before they come to our firm and after they leave our firm, we need to make a symmetric firm assumption, which with market level data, hopefully we're able to do better in the future. So with the demand model and our data alone, we can already do some welfare calculation about what's the net benefit of introducing monitoring and where is that benefit going to. So in this gray bar, I'm showing you that on average, each person that's eligible for telematics is gaining about $13 per year per year on average. Sort of if you spread out this sort of gain in total surplus to the market participant. And if you do a decomposition, you can see that consumer surplus went up and firm profit also went up because of the introduction of monitoring, but it's partially offset by the loss of profit from competitors, meaning that you're sort of stealing some consumer away from other firms, right? In particular, we rely on two things to make this calculation a little bit easier, because firms did not change the baseline price for the opt-out pool. And also through interviews, we know that the resource cost of monitoring is $35 per capita. So both of which is important for us to make this calculation. But as we have seen, drivers drove a lot better when they're being monitored. So there's this incentive effect, right? So what if we tease out that incentive effect and just focus on the informational effect, or the selection or allocative effect, right? The first thing you notice is that all of the numbers are a lot lower So most of the surplus gain that we calculated is actually coming from the fact that people drive better as opposed to superior information in this case. And secondly, sort of traditionally, we have these competitive cream skimming models that we sort of think of ensure competition in the presence of asymmetric information. But as you can see here, when you have superior information, that insurers can compete on getting better information about drivers. It actually changes our intuition about competitive cream skimming a little bit. I think the intuition here is that as you move to the sort of perfect information, perfect competition benchmark, you're very much improving the overall sort of surplus in the market while reducing firm profit. Because here, when you sum firm profit with competitor profit, is actually the overall profit actually drops. Okay, so now we finished talking about demand. Focusing on the firm, there are two main profit considerations for the firm. One is that there's this invest and harvest pricing dynamic. You have to first collect the data before you use the data. And second, you have opt-in and opt-out pool, which cannibalize and cream skims across each other, right? So basically, in our firm model, we have three main parameters. One is that you can surcharge the opt-out pool in the first period, or second is you can discount the opt-in pool in the first period. But in the second period, once you get the telematics data, you are able to determine this rent sharing regime with the opt-in drivers, meaning that if I discover that you're 50% better than I thought you were, how much of this 50% do I give it to you as a discount, and how much of that do I keep, right? So in this table, I want you to focus on the sort of bottom half here. The first thing that we did is how can the firm improve pricing to optimize their profits? As you can see, in the current regime, they are not surcharging the opt-out pool. But what we found is that this is pretty close to optimal. In the optimal pricing, they should surcharge the opt-out pool by 2.7% only. This is because when you surcharge opt-out pool, not only do they go to the opt-in pool, but they also can go to other firms. So in other words, the product market competition here is really limiting the firm's ability to coerce people into voluntarily disclose their information through telematics. Instead, what they should do is to deeply discount the opt-in pool in the first period, increasing from 4.6% in the current regime to 22%, and at the same time, share less rent by 20% less rent ex post in the second period, meaning that I'm going to sort of not give a lot of telematics discount, but I'm going to give you a lot of ex-ante opt-in discount, participation discount. This is going to overall raise the market share of telematics in the entire market by quite a lot. And then now that we have firm and demand model, we're able to analyze what would happen if you have this market level regulatory change that says, oh, as a firm, you have to share your telematics data with your competitors. Here, what we found, surprisingly, is that it actually decreased the firm's incentive to collect the data, so much so that it reduces the overall market surplus. As you can see here, it drastically changes firms' sort of incentive to offer opt-in discount. And the firm also wants to recoup a lot of the loss from sort of the loss of proprietary data by capturing more rent ex post, which overall leads to less people participating in telematics and less data being revealed in equilibrium. Okay, so I think I'm going to sort of summarize this in a little bit, but I think this is one of the main insights. So our second paper is kind of very related, digging into sort of, I think the first paper talks a lot about the information effect, but most of the surplus gain comes from the incentive or moral hazard effect there, right? So in the second paper, we very much try to sort of dig deep into this case. In particular, we collaborate with a ride-sharing company, and everyone uses a smartphone. Every driver on that platform uses a smartphone to navigate and to facilitate transactions. So we already have a lot of cell phone sensor data. So on top of that, we developed a machine learning algorithm that identifies risky driving behaviors from that data with 99% precision and 70% recall. So from these sensor data, we're able to sort of construct a lot of features based on how these kind of sensors data move. And then with a lot of actual sort of ground truth data that we collected using video and in-vehicle sensor data, we're able to actually very accurately identify, oh, are you using your phones, and are you having a harsh brake, etc. And in particular, we're going to focus on handheld phone use behavior, which is illegal. Text and drive is illegal in all US states, and handheld phone use is illegal in a lot of US states. Okay. And here I'm going to tell you, I'm going to call this HPU, handheld phone use. Okay, we see that HPU frequency jumps by 11 times in the 30-second window right before accidents happen. And using very exhaustive regression estimates, we show you that increasing HPU by 1 second per trip is enough to increase accident rate by 1%. This is using tens of millions of rides that we are able to very accurately identify this. The first thing that we did is to try to understand, is there any ex-ante moral hazard? In the sense that, is our traditional thinking that, oh, experience rating leads to better driving, is that true? And what we found is kind of discouraging. For example, HPU is 38% riskier in trips with precipitation, but is only lowered by 1%. We are able to use the same sort of technique that E used in her paper called instrumental variable to quantify this causal effect very accurately. And secondly, during our research window, the ride-sharing company reduced the insurance coverage for a lot of drivers in many states. And the reduction actually differs across states. So we try to see, does this reduction of insurance lead to any safer driving in the sense of, did they sort of not stop holding their phone and sort of like discipline themselves a little bit more, and there is just no impact that whatsoever that we could detect. We used a pretty sophisticated technology called synthetic control approach to compare across different states that reduce their insurance coverage differently, and we find no results here. What this is telling us is, I think, pretty profound in the sense that less insurance or more experience rating might mitigate claims, but it's very, it probably cannot really prevent accident in similar sense as sort of what it's originally designed to do in the 1880s, at least in the auto insurance context, I should say. So then we try to understand, why is this case? Why is HPU so insensitive to the changes in risk exposure or the changes in insurance? And one of the hypotheses that we have is that it's not because they don't value this or they don't have moral hazard. It's simply because they're not paying attention to this behavior. So we ran what we call nudging experiment, in which we sent the driver a one-time text message to the top 5 percentile in terms of their handheld phone use frequency. By the way, these top 5 percentile of drivers accounts for 76% of all of HPU miles, basically driving with HPU. And the text message just says, hi from our company. Our app shows that you may be holding your phones while driving. Passenger reports of unsafe driving, like handheld phone use, can lead to suspension. And for more information, visit this link. There's some details about the program. So as you can see, as soon as we send this text message, the 24 hours after this text message was sent, we saw a 30% decrease. More than 30, 1/3 drop on the first day. And then it sort of reversed a little bit, but still stabilized at around 15%, even a month after this text message was sent. And we further validate sort of, is there anything else going on here? We found that there's no detectable change in driving hours or other unsafe driving behaviors. We also found that similar to E's paper, like near misses or harsh braking also reduced, meaning that they actually were kind of driving a little bit better. through this change in hand-holding behavior, which really gave us a lot of confidence in the potential of behavioral modification. So with this experimental data, we estimate a kind of moral hazard and inattention combined model to try to understand how can we move from the outcome-based experience rating contract to a behavior contract that in economics we call first best contract. So in particular, we estimate 3 parameters: price elasticity of HPU, how much do they value holding their phones, in other words, and second parameter is risk aversion, and the third parameter is this inattention parameter. So how much are they sort of attention mediate the effect of moral hazard? And we estimated on the experiment sample, allowing heterogeneity across drivers and trips. So on this graph, I'm showing you the distribution of handheld phone use frequency in the top 5 percentile of HPU drivers. As you can see, the average is 9.6%. And the first best contracts, firstly, have full insurance, which raises HPU because of moral hazard. But it is immediately more than compensated by a simple nudge, which reduces the sort of average frequency of handheld phone use to below the status quo. But we can further simulate what we call socially optimal contracts to recover the moral hazard externalities to insurer and to accident victims. Here I'm calling sort of quali as quality adjusted life years externalities by charging people based on how much HPU they did. So in the first social optimum, if we charge a uniform pricing for every person and every trip, we're going to charge them $0.77 or 77 cents per mile of HPU that we record, right? And this number increases to $1.2 per mile if you want to further sort of correct the moral hazard externality of sort of these kind of loss of quality adjusted life years for victims. But if you are willing to personalize this charge based on their risk types, you can significantly reduce the charge to 40 cents and 62 cents respectively. So in equilibrium, if you're willing to personalize, in the socially optimal equilibrium, the average driver is fully insured, pays 3.8 HPU charges per 100 miles driven, and the HPU reduction alone leads to 2% fewer accidents, is our estimate. So to conclude, across the 2 papers, I think we found initial evidence that validates the theorized potential of telematics, but more research is needed to push adoption and contract innovation, as well as to understand the interaction of insurance, equilibrium, and regulations. So to answer our questions, how should firms price on telematics data to incentivize disclosure while capturing rent from the data? We show that there's limited ability to coerce disclosure, and the main lever should be an invest and harvest pricing dynamic. Oh, and to moderate behavior, we show you that inattention limits ex-ante moral hazard in the sense that experience rating or insurance reduction cannot really prevent accident. But pricing on the risky behaviors directly solves both the inattention and the moral hazard problem, which can lead to behavioral modification. And the second question, what if regulators mandate that firms must share proprietary data with competitors? We show you that large demand frictions hinder adoption while raising the cost of data collection to the firm, which means that protecting firms' proprietary data, the right to their proprietary data, and incentivized collection can outweigh the exposed concerns on charging excessive markup, at least in the beginning of the sort of adoption of these type of contract. But of course, this also further implies that, suggests that potentially there's a lot of gain to be made with government intervention in terms of centralized data collection, which can avoid duplicative effort by different firms. And also coordination by the government can potentially lead to better disclosure equilibrium. Okay, so I hope this can help us shed some light on the policy debates here. Thank you very much.
Okay, thank you. I would ask Marco Cosconati to do the double job too.
So I will discuss both papers, and Matthias Rodemeier, unfortunately, couldn't make it, but Stefano Rossi is on his way. So
It's very late.
he just
our
WhatsApped me, and I'm monitoring him. So he
black box
himself on his cell and it's on my WhatsApp, so I will, you know, fine tune with him. This is real time kind of.
He's coming.
So thanks both. Great insights. Very thorny questions. I will start with Yi's paper. So it's actually consistent with evidence that I provided and the researcher provided of the so-called state dependence. Okay, so accident, what is the effect of past accidents on your probability of having now an accident? Conditional on incentives. Some researchers I found negative state dependence. Another paper found negative state dependence. If you just had an accident, you're less likely to have an accident. And the evidence by Yi's is really striking and neat in explaining why it happens. It's a very nice paper. It's published already on Restat, so there's little I can add. But certainly, as much as Yizhou's paper kind of conceptualizes the importance of moving from outcome-based to behavior-based contracts. Okay, for the reasons that Yizhou explained very well, you know, accidents are a very noisy measure of driving attentiveness and risk itself. At the same time, this finding challenges the traditional actuarial principle. That is, more accidents means higher risk, therefore higher premiums. The mechanism, as she explained, is that traumatic events make you safer in the short run. So there are two keywords here. One is safer, and the other is the short run. In the paper, short run means about 2 weeks, okay? So when we think about designing a contract, we should really take into account the length of these effects, not to overdo in a way. And again, this is consistent with the idea that we price as insurers, or you guys price as insurers, prices for risk, that is innate risk and risk aversion, but these parameters vary discontinuously. We do take these into account in traditional actuarial models because we price on age, okay? But, you know, you only get older 1 year after another, and the paper is telling you, you may change your preferences in a much more frequent way. So, as you explained, there are two parts of the paper. One is causality, okay? And here there is a very, data-specific definition of what is a near-miss accident. These would be harsh brakes or deep acceleration defined with some sort of, I'm sure, reasonable criterion. Just to say to you in the room that collect this kind of data, we can do better than this. If we had the data, we could define near-miss accidents using gigabytes. We know that these telemonitoring devices also measure the intensity of even near-miss crashes with gigabytes. So there is a data potential to even do better than this. There is clear evidence of risk reduction in terms of many relevant behavior for accident probability, such as cellular use or distance-driven, which is really causally related to these near-miss accidents. The second part is to try to discard the mechanism which generates this. Could be purely background noise and some kind of inherent process going on, or it could be learning about your own risk, or as the paper quantifies, there is a structural change in the short run of risk aversion that is modifying your behavior and making you safer. The final one is that this reduction in accident probability that could be computed if you had access to near-miss accidents data and behavior would generate from an actuarially point of view a small reduction in probability when it's summed up over all the people and the premiums. When it comes to China, it's going to be billions of premium reductions. Okay, so let's not kind of misinterpret I think it does a very nice job in telling us do not interpret that 0.001% reduction as a small number, because it's not. Okay, so large savings if we could access to that. Now, there is, of course, some caveat which are due to data limitation. This data set is merged only to some extent with observable characteristics and claim occurrence and size of claims. So certainly a more comprehensive data set would have information on actual claim, sizes, and characteristics of the contracts that are imputed from outside sources. Actuaries here in the room might not be super happy, but they're never happy what I do either in estimating accident probabilities. Again, this partially reflects our culture as economists and partially data limitation. It's left out because of data limitation, some underlying heterogeneity in the risk, which is not fully captured by the rich driving behavior that are in the data. Behaviors might depend on further individual-specific contract characteristics that the paper might miss, but that's okay. Let me just now try to make an analogy, because when peace is hard, it's nice to me, and I'm gonna make a final statement which tells us that while the conclusion of your paper seems very unique, unambiguous, it may not so be clear-cut that the so-called real-time insurance is good, for the reasons that are mainly explained by Ming this morning. And I have a paper with a colleague that works on that, and the intuition goes as follows. So let me go by order. Risk aversion changes very frequently. There are many traumatic events. It would be nice to price risk, say, on a weekly basis. And in Italy, there are companies that do that. Okay? You give your credit card, and given how you drive on a monthly basis, in fact, or 2 weeks basis, your premium is adjusted. That's great. So people are doing that. They have agreement with credit cards. Some of them are doing the charity good thing from your results. But first of all, there is no data that supports the fact that this is true in the Italian context. So it would be nice to have similar data, perhaps in Italy. But then there is a caveat, which is not in the slide, but I'm trying to be clear, which is the following. Suppose that you price on a, say, weekly basis. It's even better than this. On a daily basis. What's going to happen is that the premium is going to fluctuate like crazy. And that's exactly what insurance is not supposed to do. So on the one hand, there is a tension here between actuarially efficient, fair pricing and social efficiency. Because remember, bread and butter of social insurance is to provide a stable consumption path, yes, across states of the world, but across time too. Okay? I have a paper with a colleague that shows this is exactly the reason, okay, why in the future is not guaranteed at all that will just be telematics. Because if premium fluctuates a lot, some people might dislike it. Guess why? Because they're risk averse. There will still be room to give standard stable contracts. So the punchline is that you may benefit consumer by giving these real-time, contracts, but may hurt in another way because you're making them worse off by making the premium fluctuate enough. Okay? And if they're very risk averse, it's going to be worse. But guess what? If they're very risk averse, insurance is efficient. If they're not very risk averse, why would we do insurance? Okay? So there is a tension between these two things when balancing and pushing this time concept that we should take into account as a study, perhaps as economists and as policymakers. So this is the first, viewpoint on this great paper. It would be nice to have Italian data and to replicate this. The other discussion is about Yizhou, and there are two papers. One of them is already under revision under a major journal, so I wish you the best of luck. I hope it gets published. It's going to be very influential. For our purposes, there are a couple of caveats that I want to make up front, which is the following. Italian issuers to me, and of course this is just showing are better than American ones, in the sense that we design contracts, and there is a great, large issuance company that can support this, I think in a better way. The US contract is a one-shot observations. I observe you one time and then I price you, okay? Italian contracts are truly dynamic. Premium time T depends on driving habits at time T minus 1, okay? So there is really truly dynamic contracts, contingent, okay? And again, risk classification kicks in, but from a natural viewpoint and the moral hazard from the moral hazard viewpoint is probably more effective. That's one main distinction for our purposes. Having said that, the forces in this paper tells us a lot for what we should do in terms of policy, not politics, policy. The first paper is Equilibrium Effects with Wasserman, and just to the main takeaways. So we have this structural model, which are great, takes a couple of years to be estimated, so we can do it, but you guys can. Insurers compete on telematics and standard contracts. That's reality. That's why it's complicated. Key feature that some people in the room will really like, gathering telematics data is costly. Telematics data do not come from the rain, they come from investment in human capital, data processing, data gathering, and development. Okay, and I'll say more about this at the end. Telematics data is not the same for all the insurers. Some insurers believe in braking, some other insurers believe in distance driven, some others believe in speed. They put different weights on these variables in terms of predictive power. That's fine. The very good thing is that they estimate price elasticity to money. This is something I did in Italy too. How large is a discount you want to give to people to make them willing to opt in into the monitoring program? And you got all the figures in the papers. There is some estimates about the effectiveness of this program in making people safer. Again, this reflects the US type of contracts. In Italy, the estimates implies about 20%, okay? If you pick two guys, observational equivalent, one with the black box and the other without, on average, the reduction is 20%. So there is large behavioral response. In Italy, there is different sorting than in the US, that's fine. What I want to stress about this, this is the first paper. The second paper, I'll say something about the two papers combined in the end. The second paper study really an issue that from the policy viewpoint is important. Penalties in Italy are large, as you will see from my estimates, 27% in terms of premium increase. If you have an accident, you get penalized by 27%. Okay, we have a mandatory full insurance regime, no deductible, but still, okay, I cannot truly believe that 27%, such a large penalty, is efficient from the economic viewpoint, okay? So the second paper tells us, look, instead of penalizing so much accidents, we should really learn the mechanisms through which accidents do not happen. And the truth is that, remember, the moral hazard efficiency is based on a very strong assumptions. The people understand A, incentives, B, risk. They don't, you can incentivize as much as they want, you're gonna penalize as much as you want, you're not changing their actual behavior. That's the main message from the second paper. And it really found that salience is an issue. And when I look at Italian contracts, or even at telematic contracts, I see no salience there. They're very complicated. Very complicated. So there might be some processing cost, which is reasonable to understand these incentives and the risk reduction related that optimal quote-quote contract should take into account. And it shows really in a very credible way, the first best versus the second best when salience and nudging is taken into account. So one thing that we could help in doing, and Anya does that all the time, but I've seen no estimates whatsoever, is this informational campaign. If you drive without insurance, you're gonna go to jail. If you speed too much, you're gonna die. The shock campaign, they do so much, we do so much of it. Little estimates about their effectiveness. So if we want to design optimal penalty system, taking into account risk mitigation and nudging, I think we should have in Italy more of these exercises. Okay, so that's my point. So overall, lots of policy implications from these two papers, but a lot of turning questions left. So this experience rating workshop will leave us certainly with not more questions, but is really telling us that, it's not that adding classes is gonna solve all the problems and making the world more efficient. First of all, mandatory data sharing. This is something that we've been talking over and over and over. Insurance companies complain. They made the right point even before you even started the paper. If you made mandatory portability of telematic data from one another, we're gonna kill telematics with no incentives. That's a typical problem we study in public. That's a free riding problem, nothing less than that. Okay? So many solutions. First of all, as he suggested, in principle, make them centralized. IVASS or some other central authority has public driving data that then can be get rid of the bonus-malus class and get driving data. Easy to do. Engineers and whoever has to do will kill themselves to do. But in principle, you might think it's feasible. Problem. Telematic data evolve over time. It's not that Unipol or Generali are pricing on kilometers for the next 10 years or are weighting kilometers the same as they were using 10 years ago. In fact, they changed their pricing schedule a lot because they're experimenting, they are investing, so they will always be, by definition, some leftover telematic data that cannot be shared. Okay? So the frequency of technological pace can be a practical impediment to these, conceptually speaking, economically correct suggestion. So that's, as a policymaker, my concern. There's alternative, though. Alternative could be do not mandate. Okay, so say it again. Mandate portability of driving data, but incentivize of whatever you're doing without centralization. You go to Unipol, to Generali, and you bring on your car, whatever you do. But incentivize supply side. Give incentives to, insurance companies that are investing and pricing on telematics. We can, as economists, compute the rent subsidy. That's what we pay for. So in practice, in theory, this could be doable. This is probably less distortive and also more cost-effective than this big, huge, centralized database that presumably IVASS or someone else would have to put up. So again, as I said, designing in relative to second paper in Italy, also experiments of this type would be really of paramount importance to design better and understand the efficiency of penalties on accidents. Okay? So this is more of a wishful thinking. And I thank you both. It was been great to talk to you and hear your observations. And I don't know if there is questions from the floor, Riccardo.
The authors, if you want to reply, please.
I think it's great. I agree.
Do the insurance company want to say? Silence. They will
Any comment? Yes, please.
I wanted to ask you about the coexistence between connected vehicles that come out from factories with embedded data and the technology that we were talking about, the OBD. How those two reality coexist as far as data collection?
I was just talking about this issue during the break. I think what I have never seen concrete data on the sort of coming actually from any automakers or OEMs. But I do know that there are, I mean, it's public information that, for example, like GM, companies like GM have actual contracts with auto insurers in the US to share in terms of data sharing. And a potential insurer can sign their data, their vehicle data away. You know, if I have a GM car, I can sort of sign that data away to my auto insurer. However, I would say, like, from what I understand, that's only very recent cars that have that capability, which is a very small portion of the overall stock of cars. So it's also, I don't think it's like a huge concern at the moment. And apparently there are additional complexities. So I'm very eager to learn more about that.
Okay, thank you very much. Very interesting and stimulating presentation, also from a regulatory point of view, since there are a lot of issues that we should consider for regulation. One of which is information sharing, which is a relevant point for future regulation, which is obviously a relevant issue, mandatory, not mandatory. Now we are in the world of Web 3.0, decentralized finance. So all this discussion of centralized data is a bit old, but somehow we need to consider this. No, my technical point of view is just one of this. How do you translate all this big data on driving behavior and risk behavior and obviously connection with the accident? How do you translate with the concept of liability of the accident? That is, the accident can be provoked, can be received. So somehow there are different ideas on this. I can have a risky driving behavior, but this translates into getting bumped and not provoking an accident to other people. So this issue of liabilities also, I think, is quite relevant, because could be my fault, could be responsibility of the other person, could be 50-50. So somehow the consideration of the accident is a bit different when I'm raising the claim with the insurance company. So if there is some kind of consideration of liability in your scheme. Thank you very much.
And I can answer for the first paper. We very much only look at fault accident. So everything is just its effect on at fault liability accident. For the second paper, you're right. We're like pooling all kinds of accidents together. But you know, it's still like, if you think everything is non at fault, then a lot of the variables shouldn't be that predictive, like handheld phone use, but it's still very, very predictive. So I think it's fair to say that even though with some pooling, you know, like it's still capturing a sense of riskiness. Or maybe like when you're holding your phones, you really are more likely to be hit by other people because you're unable to avoid it, unable to do enough to avoid it, I guess, right? So I think based on the actuarial principle, there is some sort of direct risk relationship that we can capture.
Yes.
So in our case, we're also using at-fault claims rather than, so because it's recorded under the insuree's profile, yes.
Yes, and for your paper again, the paper of Xin, just a small curiosity, if the flows of traffic or the number of lanes could help in your analysis. If the traffic flows or the number of lanes would help in your analysis, admitting that it is possible to gather this data.
Yeah.
I think he means information on the context, like congestion.
Yes,
and stuff like
yes, for sure.
Did you ever think of in the design of your data to include this data?
Yes, we actually you're talking about the congestions on the road, the traffic, right? So
yes, environmental data.
Yes, we actually did include some control variables to measure like how congested the road is while you were driving. I didn't show that result, but it's inside our X variables. It does have an impact on the driving behavior. Yeah.
Marco, it's still your turn because our last paper is from Marco Cosconati, Market-Wide Moral Hazard and Price Walking in Automobile Insurance. Please.
Okay, so I won't keep you long away from lunch. We'll try to be brief, and Stefano could also reach us. So this is paper that has been had some, long gestation. The goal of the paper. So I try to relate a little bit the motivation, which is to quantify moral hazard with respect to the goal of this workshop, which is try to understand how to change bonus-malus system. And one of the reasons why bonus-malus system is there is to make people drive better, because if you have more accidents, your premium goes up. So the insurance company can freely use this information to incentivize safe driving. So the mechanism, as I said, I will discuss a little bit at the end. Hold on, introduction. Let me just show you a little bit of what can happen, what could happen, and why is it important to move to understand moral hazard when we think about giving to the market more information. So this is an hypothetical schedule that maps number of accidents into premiums. And suppose that the market is insurer A before we give information, and it becomes insurer B after we give information. Well, this information really is making what is on the x-axis more coarse. Instead of having 0, 1, 2, 3, 4 number of accidents, you're going to end up having 0, 0.5, 0.7, okay? So this is what really means giving more information. We're having more classes, using traffic violations. We're using whatever variable is going to collapse in a almost continuous measure of driving records, okay? So now what happens is that insurers here face a schedule. If I drive better, if I have 3 accidents on record, and I have another accident, then I'm covered by insurer B, my premium will go up a lot. If I'm covered by insurer A, my premium will go up, but not as much. Okay? So now, what I do as a policyholder, and this is really the essence of moral hazard, I respond to how much the premium increases. Okay? That's the penalty, given the current experience rating system. The goal of this paper is to estimate and get rid of some, econometrics problem, the effect of penalties on accident frequencies. Okay? This is relevant because if there is no moral hazard, if people just do not respond to incentives, then the change of these curves before you give information, after you give information, is not going to affect the frequency of accident before and after the more information policy. Okay? So as policymakers, we want to have an idea what is the current moral hazard effect. And then if we also knew how hypothetically insurers would use this more information to penalize accidents, then these estimates could be informative of the effect of the more information policy on costs, okay? On the frequency of accidents, and therefore on premiums. This is important because one conceptual point I've been hearing over and over about this debate about bonus-malus reform is that the bonus-malus reform is just a redistribution of premiums. Someone was paying a lot before, now is paying less, but this is offset by someone who benefit from that or got damaged by the new policy. With moral hazard, this might not be the case, because if insurance companies change their behavior, in response to the information. If policyholders respond to incentives, then the frequency of accidents change, and the average premium will also change. Okay? But we should really agree, I think, to have a fruitful theoretical discussion and informed policy discussion that reforming bonus-malus is not just necessarily redistributing premiums from one consumer to another. It's not. How large is this non-redistribution effect and this mean effect? It also depends on the parameter I will tell you now. So moral hazard is very much of a debated causal effect in the literature. Some estimates, even now the insurance find no effect. Some other people think it's just exposed. I think it depends a lot on the context and the incentive at stakes. I don't think we should be too much worried about finding a unified answer to these questions because institutional and pricing strategies change. So we should be bringing a lot of body of literature and try to reconcile a bit the results. This is, I think, what we should do. Typically, the literature does not distinguish between state dependence, which is this paper, and moral hazard. That is, am I driving better because I'm shocked and therefore I drive better, or am I driving better because I had an accident and therefore my premium went up, and if I have another accident, the cost will go up even more. The second limitation is that in the literature, agents do not switch insurers strategically. That is, in order to avoid a penalty if I have an accident, I may know that there is an outside option. So I switch, and I can at least partially neutralize this penalty. And we want to understand and quantify market-wide moral hazard. I think this switching is important. The other issue that we don't quite understand in moral hazard and that pertains to reforming bonus-malus system is the trade-off that insurers have and that your paper tells us something about between retaining a consumer and penalizing him from the accident. If I penalize him a lot, he's going to drive better, but he may leave. Okay, so that's a trade-off that makes insurers' job quite difficult in setting the right penalty to maximize profits. So these are kind of some of the questions I asked in this paper. First one I was worried about, do people really know about the penalties? Do I know that when I have given my driving a 20% increase, do I respond to that? That's one issue. The second one, which pertains to this switching kind of asset option, is how premium varies with tenure. Okay? Because if I know that when I switch, I'm going to have a huge new customer discount, okay, that discount will essentially compensate the penalty that I could have at the current issuer. So then we're going to estimate this elasticity, and then I will also wonder, do I respond empirically just to the penalty that the current insurer enforces if an accident, or also to the penalties by potential insurers? Okay, these all kind of ingredients make me talk, I think, in a deeper way about market-wide moral hazard as opposed to the single insurer moral hazard. So this is kind of the main equation. I'm going to go fast on this, then Stefano will have a discussion. This is, how important it is to allow for competitors' pricing when you want to understand moral hazard. So imagine you have an equation which relates probability of an accident to your characteristics to the penalty, given your driving record, given bonus-malus class and number of accident records enforced by the current insurer, and you ignore the switching option. Well, basically what you're doing, you're going to have an omitted bias, and if you work it out, you're going to have this other equation which takes into account the current penalty only is there, it should be weighted by the switching probability. There's going to be the other insurer pricing. If you don't take into account competitor pricing, you're going to misestimate moral hazard. Okay? So let me just then tell you a little bit about the Italian market. I'm going to be quick. To estimate the premium regressions, and I'm going to estimate the effect with my data of driving records and tenure on premiums. the driving record effects are going to be company specifics with some, grouping. I get rich price variation. And what I get out of this rich regression are two messages. The first one is that the Italian market is enforcing, on average, a price walking strategy, meaning that as you get more loyal, conditional on characteristics, premium goes up. Or put in a different way, conditional on the same characteristic and plan, new customer receive a 92 euros discount on their premiums relative to all customers. Okay? Why is it relevant? If I know that my penalty, if I have an access, is 100 euro, but I know that if I switch, I have a 92 euros, effectively, I can neutralize current penalties by large amount. Okay? This is why it's important when estimating the effect of penalties to take into account this price walking strategy and premium enforced by and penalties by potential insurers. So I'm gonna give you just other results. When you have an accident in Italy, on average, your premium will go up by 27%. This is an extremely large penalty, which probably is capturing the fact that we have mandatory full coverage. There is no deductible. So it might be the case that these penalties, in fact, also doing the job of a deductible in a sense. It's also taking care of selection in a way, or asymmetric information beyond moral hazard. There is heterogeneity across insurers. So these effectively tell us that the assumption of symmetric insurance might be restrictive, at least in the Italian market. When you change in company, reduces the average penalty to 35 euros as opposed to 127 that you will get if you don't switch. So punchline is that switching neutralizes much of the current insurer penalties. Not penalties overall, but current insurance penalties. So then the other insight we get from this estimate is that if insurers want to enforce to incentivize safe driving, is going to be key for them to keep people around. Because if I know that I switch, then current penalties are not going to be effective. So then the other things we learn is that, this is a graph I don't show, is that the retention pattern, this is switching probability, mirror images the price walking strategies. When you if you are a new client, your probability of switching is much lower than an older client. And this is just coming, obviously, from the price walking strategy. So then, yes, I'm done. So the mechanism is, premium increase, switcher obtaining discount, and the reason why insurers give discounts to new customers is because they can incentivize them through the moral hazard effect because they're not going to switch. This is what's behind this. So I think I'm going to switch this. I'm going to just give you the results. So I found large moral hazard effect, but the effect kind of shrink when you take into account competitors' pricing and switching. This is exactly consistent with the first equation and the limited variable bias that I illustrated you at the very beginning. So I'm just going to end with the policy implications, which is just follows. So standard theories tell us that if we give more information, so let me say it in a different way, penalty equals moral hazard plus asymmetric information. This is adverse selection. Okay? It's inefficiently high because to some extent the absence of a deductible makes this penalty too high. You give information to the insurer, let's say you eliminate the adverse selection part. Now the insurer are going to know exactly who you are. But then by this simple conjectural equation, penalty will go down because it will just be there to correct moral hazard. But if penalty goes down, when you give more information, because there is moral hazard, accident will go up. Okay? And if accidents go up, then premiums will go up. So we should, the punchline is that we should be very careful about the side effect of giving more information, more public information. Because if there is moral hazard, penalties that Unipol or Generali are going to enforce might, because of competitive pressure, decrease, and therefore in equilibrium people will drive worse than they're doing now. Okay? So another turning trade-off to take into account. So that's what I wanted to say. And
thank you. Stefano Rossi from Bocconi eventually arrived. Thanks a lot.
Thank you very much for inviting me to discuss this very exciting paper. I made it, after a non-trivial journey. But I'm also acutely aware that I'm standing between you and lunch, and I want to really, make sure that you know that our incentives are perfectly aligned, precisely because of that non-trivial journey. Okay, so thanks a lot for inviting me to discuss this very interesting paper. Phenomenal data, matched insurer-insuree. It's easily interpretable as the population of contracts ex ante and claims ex post. 50 plus companies, millions of contracts over a representative time period. This allows to credibly study the equilibrium in the car insurance market. Okay, and there are two features of this paper that are really important. Obviously, the fact that we are approaching the population. Second, this is as you all know, of course, this is a mandatory insurance contract. So the one endogeneity layer, the fact that people may choose to insure themselves or not, is removed because they have to get insured. And this is very important for the economics that we can get. And so the main objective here is really to gauge how the policy price, premium paid by the policyholders, varies with the driving record, okay? And one would, we all want to be safer on the road, right? We want to be safe in knowledge that basically risky behavior is warded off the streets. So we would expect that higher penalties drive accidents down, and this elasticity parameter is ultimately crucial for policy, so as we have just heard. There are two mechanisms that need to be disentangled. There's moral hazard in the usual sense of risky behavior of the insuree ex post. So if the insuree knows that no matter their driving attention, the insurance premium is going to be flat, then they are likely become less attentive. Therefore, there is this idea to incentivize good behavior, safe behavior, called experience rating. Premium declines with clean record at the individual level. There is also an idea of adverse selection. The fact that you might be writing contracts to riskier types ex ante, and this is particularly important because if competition is imperfect, different insurance companies may attract, or may even at the end of the day cater to, different market segments. Therefore, as a result, both moral hazard and adverse selection are likely relevant in equilibrium. So, and it's very hard to disentangle these two forces. There are three main challenges. There is sorting of individual policyholders into different insurance companies, which in turn impose an heterogeneous penalties and heterogeneous premiums, likely reflecting different cost structures. Then tenure profiles, how the premium changes over time for the same employee as a function of loyalty, is likely relevant and needs to be disentangled from other effects from a simple cross-sectional snapshot. And then perhaps even the biggest challenge of all, having a menu of insurers that offer competing contracts at any point in time for any policyholder means there is a menu of outside options. Okay. These challenges in the traditional paper in this literature are basically not addressed simply because the data is not there. The rich data here allows to essentially observe the population in a setting with mandatory insurance. And by focusing on switchers, people who change insurance company, this allows to account for all time invariant characteristics of the insurance companies, so the cost structure, the premium and everything, and also for the time invariant characteristics of insurees, so the ex ante riskiness, the fact that some people drive better than others, just because of an innate characteristic. This allows to really focus on the incentives to drive more attentive or less. And also there are all the locations and time fixed effects. Furthermore, the data allows to estimate rich tenure effects. Okay, and the intuition, therefore, is that by using this variation across insurers, within insurers, and also across locations, and accounting for all this heterogeneity, all the effect is identified, all the effect of accidents on premium is identified by insurers that switch, okay? And they are basically insurers who likely switch for incentive reasons, not for time invariant reasons. And prior literature had typically data on one insurer only, so you can't do that with data on only one insurer. The findings, and Marco just told them very well, so you would expect, as we have said, in the case of moral hazard at the individual level, you would expect that with loyalty over time for the same matched pair insuree-insurer, the premium to go down when basically the driving record is clean. Okay. Now, controlling for that and also for all individual characteristics, the main finding is in fact the insurance premium goes up over time within the same matched insurer-insuree pair. That's price walking. It's the opposite direction of this experience rating effect. I didn't know this, and I think it's shown. Typically when we when in the presence of empirical papers, we tell students, let the data speak. Now here, not only does the data speak, but it actually sings, and it sings a beautiful area, okay? So that's really, really nice. So the switching probability goes up, furthermore, after basically the policyholder has an accident or a penalty is enforced. So basically the people who switch had just had an accident. They are expecting the insurance to go up within the current policy, the current insurance company. There is this glitch, we heard in some sense that some of these records get erased if they switch, and they do switch they do. So in a sense, the effectiveness of these penalties increase after a dirty record gets neutralized by this price walking. And Marco calls this market-wide moral hazard as opposed to individual level moral hazard, because there are these two features in equilibrium. The safe drivers subsidize the risky ones. There is a redistribution. Safe drivers who stay loyal pay 92 euros more, and this basically subsidize the discount that the risky drivers that switch obtain when they change insurance company. The implication is that to maximize profits, given all this increase in public information, what's left to compete for is actually the lemons. Okay, and it makes perfect sense only after you've seen the whole data, because ex ante you say, oh, I've never heard anything like this. But if you see the effect of, if you see the data, it's actually crystal clear. I have, so it's fascinating, striking, and it's really an equilibrium paper, which in empirical research is very rare. So I strongly recommend you read it. I have one main suggestion. The topic today is experience ratings, right? But the main finding is that the net effect is one of price walking. This is the opposite direction of experience rating. The fact that with loyalty, the tenure effect, the premium increases. Now, likely there is also an experience rating effect, okay, for all the reasons that we have heard before, which implies that the price walking estimate is actually a lower bound, and it would be actually very useful to try to get at quantitative estimate, a separate quantitative estimate of the experience rating effect, okay? And how to do that? I mean, with this data, I mean, there could be many, many ways to get at that. Now, one possibility is, for example, consider a counterfactual world in which there is no price walking, and look at the tenure effect in this counterfactual world. And how do you gauge that? You can exploit variation in accidents and in claims, you know, find a local market with essentially no competition, okay, and few accidents or few or no accidents, and therefore also few or no switches, and, you know, look at the tenure effect there, and this would give you an estimate of the experience rating effect. So how does that compare, basically, with your equilibrium estimate to get a quantitative estimate of the opposing effect? Okay, so, and the other suggestion is really to kind of help the reader break down all the many pieces, because there is a lot to like in this paper, and, you know, you don't want to sell yourself short by kind of giving away a lot of the great work that you have done here. Thank you very much.
Marco, can you quickly reply or no?
More insight of how delicate it is to reform experience rating, because clearly these two things in equilibrium are related. If you change experience rating, you're gonna change price walking too. How in which direction? I don't know. It's hard to say, but prices will change too. Therefore, again, changing experience rate will not, even for this mechanism, on top of moral hazard, result in simple distribution of premiums. So that's what I get, you know, for policy.
Thank you very much. We have finished our first part of our meeting. I would like to thank all the speakers.